Let's do an example of using Newton's second law in problem solving. In this example, we'll figure out why riding in an elevator can give you a weird sensation of weightlessness or extra weight depending on which way you're accelerating. So let's say there's a person standing on a scale in the elevator that's accelerating upwards with some acceleration a. So we want to know what the scale reads. First, we need to really understand what the scale measures. The number that it gives you is related to the normal force that you are exerting on the scale. So this is a Newton's third law pair force to the normal force that the scale exerts on you. So if we can figure out the normal force on the person from the scale, we'll know what the scale should read. Now let's set up our coordinate system. I'm going to assign the upward direction to be positive y, and since the only forces in this problem are acting vertically, I don't need to define another direction. I'll pick the system to be the person. Now I'll think about what we know and what we don't. Since that person is standing in the elevator, not jumping, not moving otherwise, they must be accelerating upwards with acceleration a, the acceleration of the elevator. I also know the mass of the person, so now I have one side of Newton's second law. Now I need to think about what vertical forces are acting on the person. First, there's the gravitational force pulling the person down. This gravitational force does not depend on the acceleration of the elevator because the gravitational interaction is just between the person and the earth. So the force is minus mg. Finally, I have the normal force that's holding the person up. This is the normal force from the interaction between the person and the scale, and so this is the unknown quantity that I'd like to know. Let's look at Newton's second law. On the left, I have Fn, the normal force that I'm interested in, minus mg, the gravitational pull from the Earth. And on the right, I have m, the person's mass, times a, the acceleration of the elevator, and therefore the person. Notice that when the elevator is accelerating, the normal force and the gravitational force do not have the same magnitude. That is, they don't cancel out. So now I can solve for Fn, and I can find that it's just m times the quantity a plus g. Have you ever noticed that at the bottom of an elevator ride, when you're accelerating upward, you feel heavier? And at the top, when you're decelerating, you often feel lighter? You can see that if I change a to minus a in this example, that I'll get the normal force is equal to m times g minus a. And this explains that feeling of lightness. It's always good to check that your answers match physical intuition. And I encourage you to go and play with elevators and other physical phenomena around you while you're going through this course to see if your answers make physical sense.